Software-defined networking, also known as SDN, has reached a level of maturity where it is delivering real value within the data center at the packet switching and routing layers. But it has not been extended to the transport layer nor matured yet in the wide area network. Infinera is pioneering a new solution called the Open Transport Switch, which extends SDN and its benefits to the optical transport layer. We call this Transport SDN. Today, networks are often deployed and managed as multiple independent layers with different vendors across multiple domains. This approach leads to high operational costs and non-optimal resource utilization, and additionally makes it very difficult to provision new services quickly. Transport SDN facilitates multi-layer, multi-vendor control and automation by virtualizing and abstracting the network into a simple, flat representation.
ESnet is a US Department of Energy national facility that connects all the DOE labs together and enables scientists to get data for their research globally. It is a high-speed Tier 1 network, and we have just upgraded our network to be 100 gigabits per second capable with access to spectral capacity that will allow us to expand to 4.4 terabits per second. Science is actually going through a digital revolution. We see two very different kinds of traffic trends. One of the trends, which is kind of burst flows but huge flows, which we call the elephant flows. This is when somebody tries to move a petabyte of data from one location to another. And then these labs have people like you and me, which are browsing the web, looking at videos, publishing papers, reading things that are what the mice flows. And what we need to make sure is that the elephant flows do not trample or affect the mice flows, and both of them get the performance that they need. So in this demonstration, what Infinera, ESnet, with the help of Brookhaven National Labs in New York, did was to take a big data application that could move the data at 40 gigabits per second and allow the network to be configured dynamically, either explicitly, which means each optical device on the path was configured using OpenFlow, or implicitly, where you used a combination of OpenFlow and existing protocols like GMPLS.
The goal of the demonstration was to be able to set up circuits within the optical domain, but instead of using traditional configuration methods, to use the OpenFlow commands and along with extensions that are specific to the optical transport layer. This was done through a couple of things. So the Infinera folks had to essentially modify their box to be able to enable to take OpenFlow commands. And on the other side, we actually do have a provisioning software that's called Oscars, and we had to modify that to essentially provide those OpenFlow commands to the Infinera equipment.
So let's step through the process of setting up a 40 gig service using SDN application. In this setup, we use Oscars, the SDN application developed by ESnet. It provides a simple GUI to manage connections for its users. In the GUI, I select the source node and the destination node of the 40 gigabit Ethernet service. Those nodes are the Infinera platforms that are communicating to the SDN controller using OpenFlow and its extension. Then I enter few node key parameters, including the speed, 40 gigabit, and the name. Once done, I enter activate, and the circuit goes up in no time.
This demonstration is an important first step in the way of multi-layer software-defined networking. It shows that OpenFlow can be used not only to manipulate packets, but also flows at the optical layer.